All right, so we looked at algebraic proofs, and we looked at them just with algebraic equations. Just given an equation, can I solve for it? We're going to see that this concept still goes on with geometric proofs. So there's a few things that still are the same. First, reflexive property. Reflexive property, again, says something always equals itself. Exactly the same here, exactly the same here. If I was looking at angles, it might look like this. Angle 1 equals angle 1. Exactly the same. If they're not exactly the same, it's not reflexive property. Symmetric property is that flip-flop property. So if AB equals CD, then segment CD equals AB. It flips. They're exactly the same, but they flip. They're not, I guess, exactly the same. They're different, but the equations are the same. Same thing with angles. It's same property. Symmetric property says if angle 1 equals angle 2, then angle 2 equals angle 1. I can interchange them. And then transitive property, remember, was that when three things equal, so if AB, segment AB equals CD, and CD equals AF, so I have these three segments, AB, CD, EF. If AB is equal to CD, and then CD to EF, then AB is equal to CF. And the same thing happens with angles. If angle 1 is equal to angle 2 and angle 2 to angle 3, then angle 1 is also equal to angle 3. Same properties we saw with variables and numbers. So we're going to use kind of these properties. So here we have, I'm given angle FGJ. FGJ is congruent to JGK. And then angle JGK is congruent to KGH. So that's all given. And then FGJ is equal to 6x plus 7. And KGH is equal to 8x minus 5. I want to make this proof. So same thing as we started with algebraic. It's just a little bit more steps. So statements here, remember that's kind of like your steps and your reasons. So I'm going to always start with given. So angle F, I'm going to write exactly what I'm given. FGJ is congruent to angle JGK, and angle JGK is congruent to angle KGH. And then I'm also given that the measure of angle FGJ is equal to 6x plus 7, and the measure of angle KGH is equal to 8x minus 5. So if all this stuff is given, and the reason I can write that was because we're given. So I'm going to just kind of start with what I have here. I have one angle equal to a second, and the second equal to the third. And there's a property that kind of talks about when I have one thing equal to 1 and the second equal to the third, then the first is equal to the third. So I can go and say that angle FGJ is equal to angle, or congruent, I should say, to angle KGH. Because if 1 is equal to 2 and 2 is equal to 3, then 1 is equal to 3. So that is the transitive property. And I'm not going to have you writing these right away in your homework tonight. Mostly you're identifying these properties. But you should kind of get used to them. So the more we see, the more we're going to get used to them. So since these are congruent, then they're equal. And FGJ, we were told, equals 6x plus 7. So I can substitute 6x plus 7 into this FGJ. So 6x plus 7 equals KGH, but KGH equals 8x minus 5. So I'm going to substitute that in. And that was substitution because I put it in for it. All right, so now let's just solve out. So I'm going to subtract 6x from both sides. so that I get my x's together. That is subtraction. That gives me 7 equals 2x minus 5. And I substituted that in. This is kind of should be review. I substituted 7 in on this side because this equals 0. And I substituted 2x for this on the right side. All right. Now I'm going to add 5 to both sides. So I'd get 7 plus 5 equals 2x minus 5 plus 5. Now I'm going to move numbers to this side. So that was addition. And when I simplify that out, I get 12 equals 2x. That's substitution because I substituted 12 in for the 7 plus 5 and the 2x in for the 2x minus 5 plus 5. So that is substitution. And then 8, I'm going to divide by 2. Both sides by 2. That is division. And then the last step is to simplify it. So 9 would be 6 equals x. So that would be substitution. And notice we are where we need to be. You could flip that and use symmetric property to flip it, but I would take this totally as your proof. So just kind of wanting to be able to recognize where I can go from one step to the other. And again, sometimes it just takes seeing it over and over again. So we're going to just see a lot of this. All right, let's look at another one here. So I'm given CD is congruent to EF. I'm also kind of given some things about CD and EF. So I'm going to write that out. So here's my proof. So I'm given that if CD is congruent to EF, I'm given that. I'm also given that CD equals 3y minus 9, and that's in the picture, and EF equals 15. So that is all given. One in the picture and one up here in the writing. So since CD equals 3y minus 9, I can substitute that in for this. So I can put 3y minus 9 here for the CD and 15 in for the EF. That is substitution. So we kind of done this already this year. We just haven't written it out as steps. So now I'm going to add 9 to both sides to move that 9 over. It's attached by subtraction. So I'm going to add 9. Addition is what that step is. And then I get 3y equals 24. That would be substituting that in, 3y in for this side and 24 in for the 15 plus 9. So it's substitution. And then I'm going to go ahead and divide that 3 because it's attached by multiplication. So to undo multiplication, I'm going to divide. So I get y, that was division. I'm going to tell my reason here that of why I know I can do that. Division property of equality. And last one, y equals 6, and that is substitution. Great. That is the extension of that lesson. So you can go ahead and try that again. It's mostly naming your properties on, it is all naming your property on your homework.